In this video, we're given the function f of x is equal to 3x minus 4 over 2x, and we want to use that to find the composition of the original function with the inverse function evaluated at 0, so the f of the f inverse of 0. Now, in a similar video titled the same thing, except for instead of saying short way, it says long way, I went through this process and I went ahead and found the inverse function. And then I talked about what we could do to figure out what the answer was if we wanted to take the inverse function and then compose it with the original function and plug in 0. But that's the long way to do it. And by long way, I mean the really long way. The short way is we're just going to take advantage of what I have written in green over here on the right-hand side of the screen. And that's going to enable us to not even have to find the inverse at all or evaluate anything really. And that is that if you compose the original function with its inverse, or if you compose the inverse with the original function, and you're just plugging in, just the value of x, if that's the original value, then it's always going to equal x. That's part of the definition of two functions being the inverse of each other, is if you compose them, you get x both ways. And so for this particular problem, it doesn't matter what the original function f of x is equal to. We know that the f of the f inverse of x is just going to be equal to x. And so therefore, if we wanted to evaluate instead of the value of x, if we wanted the f of the f inverse of, say, 0, then all we would do is plug 0 in the place of what we got in the original function. So that just really boils down to plugging 0 into the place of x, which gives us 0. And so our answer to this problem is just 0. And any other problem like this, it doesn't really matter what the function is to start out with. If it is a function that does have an inverse, then if you compose them, it's going to be x, and then whatever value you plug in the place of x, that's going to be your number. So the answer here is, of course, 0.